Welcome to your next video about sequences. We're finally in our last unit before the EOC, so I hope you guys did well on your benchmark this week and you are ready to get back started before we start reviewing for the EOC. So we're going to talk about sequences. We have Ben, Sven, and Glenn that are having a contest of who could create a pattern of numbers that increase to at least 1,000 the fastest. So on your paper, you have how they decided to start their sequences. And you're going to kind of think about which patterns you see in the sequences of Ben, Sven, and Glenn. And think about which pattern of numbers do you think will reach 1,000 first. So you go ahead and circle one of the names that you think is going to reach 1,000 first. Well, if we think about these patterns and look at 20 to 40, and 40 to 60, and 60 to 80, I hope you're noticing that they're adding 20 to each one of those. So your next blanks would be 100, 120, and 140. Sven he started a little bit higher. So he started at 102, and he just added 2 to each one. So I hope that you can fill in that pattern as well. I have no doubts. So for Sven, we'd be at 110, 112, and 114. Glenn took a little bit of a different approach. If we look at this, it looks like he adds 8, but 16 plus 8 is not 32. Actually, what Glenn is doing is multiplying by 2. So he was doubling his number every time. So he started at the lowest number, but as he started to double his number, it started growing very, very quickly. And by the time we get to the 7th term over here, he's already halfway to 1,000. And if we continue this one more term, Glenn would definitely win. So I hope you circled Glenn. If not, it's not a big deal. Then you have some space to describe in words how you found each of the new terms. We talked about it, so you can describe in words on your own. So we have two different kinds of sequences, arithmetic sequences and geometric sequences. We've discussed arithmetic sequences before Christmas break, and so we're going to review it a little bit, but we're kind of spending most of our time on geometric sequences. For arithmetic, we are only adding to get to our next term. In geometric, we are multiplying to get to our next term. So then you have some blanks to fill in. We have this example. In the arithmetic sequence, a constant is added to get each new term. This constant is called a common difference because you subtract the previous term to get this value. So if we're looking left to right, we're adding. And it's called a common difference because you have to subtract from the previous term to get the value. For example, 10 minus 3 is 7. So we have to add 7, and the difference between the two is 7. However, in the geometric sequence, a constant is multiplied to get to each new term. This constant is called a common ratio because you divide by the previous term to get this value. So you can think about it as, what do I have to multiply to get to the next one? And if you're not sure, then just divide these two numbers. 6 divided by 3 is 2. So I'm multiplying by 2. My ratio is 2. So before we go on, we have a few things that we need to, some notations we need to talk about. We've talked about all these before. This is a quick review that T1 means the first term. So the first term in a sequence. If you're thinking about like an XY table, that means that the X is 1. That's your first term. Tn means a new term. It's been a while since we did a video. My handwriting is suffering. And then Tn minus 1 would be the previous term. And I will show you where those terms are located. So for this formula, for the arithmetic formula of how you find the new term, if we're looking for the new term, or like the next one that comes in the list, we take the term before it, and remember arithmetic we're adding, and we add the difference. In geometric, to find a new term, you take the term before it, or the previous term, and you multiply by a ratio. So be sure you get those down. So just to review our vocabulary, this would be T1. If I'm looking for what comes next, this next number would be my new term, and this number right here would be the previous term. So remember, to find the common difference, I do 10 minus 3, which is 7. So if I look at my formula, to find the next term, I take the previous term and I'm going to add 7 to it. So this is just an example, it's not on your paper. I just wanted to show you where these things are located in a sequence like this. So you would take the previous term, which is 31, so I'd have 31 plus 7. So my next term would be 38. And this is just showing us that we're adding 7 for each one. For geometric, focus back on that formula. The 3 is my first term. If I wanted to know what comes next, or the new term, that would be T of n. And this 48 right here is the previous term. We don't actually subtract things with this n minus 1. This is just telling us the previous term. So if I'm looking for a new term, I take the previous term and I multiply by the common ratio, which in this case I'm multiplying by 2. So I would replace this with my previous term, which is 48, and so my new term would be 48 times 2, or 96. And this is just showing you that you're multiplying by 2. So we have a few examples at the bottom of your paper. The 12, 15, 18, 21, 24, our term 1 is 12. And then I'm adding 3 each time, so 3 would go in that blank. Notice if I add a number here, then my sequence is increasing. On this one, I have my first term is 40. This is T1. And my difference, I'm adding a negative 5. So my recursion formula would be negative 5. Notice that if I add a negative number, my sequence actually decreases. Next, some geometric sequences. 3 would be the first term. And in this case, I'm multiplying by 2. So 2 would be the ratio. It's okay to write like this, or it's okay to put the 2 at the end. Remember, if we're just multiplying, it doesn't really matter. If I multiply by a... Mason and Micah just messed up the video. They want to say hi.
Hi. Hello, guys.
They're leaving now.
We need the homework.
You need homework. Micah needs homework.
Mike.
I do apologize for the interruption. Micah needed homework. Go figure. So, as I was saying, if you multiply by a whole number, your sequence will increase. And then your next example, our sequence is decreasing. Our T1 would be 125. And remember, we can use these numbers to figure out the ratio. So you can use any of the numbers. And I can do 25 divided by 125 to determine that my ratio is 1/5. So I'm multiplying by 1/5. So if you have to multiply by a fraction or a number less than 1, your sequence would decrease. And there it's written in a better way for you. So a few things to think about, and you're going to have to answer these questions on your feedback. Every arithmetic sequence has a common blank, which means you blank to one term to get to the next term. So think about your vocabulary words that would go in these places. And geometric sequences have a common blank, which means you blank to one term to get to the next term. So just as a hint, we're talking about whether you're adding or multiplying. And then these are those vocabulary words for the number that you're adding or multiplying. And then this is kind of what I just talked about, but it's just something to kind of keep in mind. The difference that makes a term increase would be a positive number, and a difference that makes it decrease would be a negative number. In a geometric sequence, what kind of common ratio makes the terms increase? That would be something bigger than 1, and makes it decrease would be something that's smaller than 1. So be sure you go and do your feedback. There's some of these questions that are on there, and I'll see you in class.